Hi there. Today we're going to be looking at section 5.4, the sum and difference formulas. So one of the things that we're going to be doing is these sum and difference formulas. And notice that there are sum and difference formulas for both the cosine, the sine, and the tangent. Make sure that we know these formulas and how to execute them. So what we're going to do is just kind of practice executing these, okay? So I'm going to find the exact value of the sine of 2 pi over 3 minus 3 pi over 4. And just to kind of give you a little background, notice that if you were to make common denominators for this, you would want to have a common denominator of 12. And so, oops, I closed the parenthesis early. You'd want a common denominator of 12. And what we'd end up here is multiplied by 4, so this is 8 pi 12ths, multiplied by 3, so this is 9 pi 12ths. And notice that this is really asking us to evaluate the sign of negative pi 12ths, okay? So negative pi 12ths on its own is not on the unit circle, right? But if we rewrite it in terms of these critical angles that we know from the unit circle, then what we can do is we can use these sum and difference formulas. Whoops. Okay. All right. So we notice that this is sine. And so then we can see that we can use the difference formula for sine. So it says that when we have the sine of x minus y, we're going to take the sine of the first, so the sine of 2 pi over 3, times the cosine of the second, so the cosine of 3 pi over 4, minus the sine of the second, so the sine of 3 pi over 4, times the cosine of the first, which is 2 pi over 3, okay? Well, because we've used these critical angles, we now can evaluate these, right? So the sine of 2 pi thirds, that's in the second quadrant, so that's going to be positive root 3 over 2. 3 pi fourths, this is also in the second quadrant, but the cosine is going to be negative in quadrant 2, negative root 2 over 2. The sine of 3 pi fourths is positive root 2 over 2. And the cosine of 2 pi thirds is negative 1/2. Now, I know you don't have to write the the plus signs. I'm just kind of making a point to think about your signs in this case, okay? So if I multiply these together, that gives me negative root 6 over 4. And then if I multiply here, I have root 2 over 4. And I have two negatives, which is going to become a positive. Notice that we have the same denominators, so we can just say that the sine of negative pi 12, since that's what was equivalent to, is going to be equal to negative root 6 plus root 2 all over 4, okay? So we'll combine our like terms, well, our like fractions at the end. These we can't combine together, okay? So now it says use the sum and difference formulas to find the exact value of the sine, cosine, and tangent of 7 pi 12ths. And they were nice enough to tell us that 7 pi 12ths is the same as 7 pi 6 plus pi fourths. So we're going to use the different sum formulas. If we look back on our formulas, it says that the sine of basically x plus y, so I'll write it like this. So the sine of 17 pi 12ths is going to be the same as the sine of 7 pi 6 plus pi fourths. And if we look at the sum for sine, what we do is we take the sine of the first times the cosine of the second, and then we add the sine of the second times the cosine of the first. Okay. And then we can evaluate. So the sine of 7 pi 6, that's in quadrant 3, so that's negative 1/2. Pi fourths is in quadrant 1, so that's positive root 2 over 2. Sine of pi fourths, again, is positive root 2 over 2. And cosine of 7 pi 6 in quadrant 3 will be a negative root 3 over 2. So here I have negative root 2 over 4. This is going to be a minus root 6 over 4, since I just have one negative sign. And so that means that the sine of 17 pi twelfths is negative root 2 minus root 6 over 4. So, I mean, as you guys are seeing, like, legit, you're just using the formulas and substituting them in and going from there. Like, that's about it. Okay? So let's use the cosine. Okay? Similarly, the cosine of 17 pi twelfths, we're going to think about as the cosine of 7 pi 6 plus pi fourths. And if we look at the cosine formula, what we do is we take the cosine of the first times the cosine of the second, and then we use the opposite sign, so minus the sine of the first times the sine of the second. And then again, we evaluate. The cosine of 7 pi 6 is negative root 3 over 2. Cosine of pi fourths is root 2 over 2. Sine of 7 pi 6 would be negative 1/2. Sine of pi fourths is root 2 over 2. So I end up with negative root 6 over 4. This is going to be plus root 2 over 4. And so we'll say that the cosine of 17 pi twelfths is negative root 6 plus root 2 over 4. You can see that a lot of these problems end up looking very similar because of the values of the unit circle that we use. You know, they're all very similar to each other. Okay. All right, so lastly, let's do the tangent. So the tangent of 17 pi twelfths, we're going to think about as the tangent of 7 pi 6 plus pi fourths. And if we look at the sum rule for tangent, it says that what we do is we take the tangent of the first plus the tangent of the second and divide that by 1 minus the tangent of the first times the tangent of the second. Okay. So once again, we'll evaluate. The tangent of 7 pi 6 is positive root 3 over 3, and the tangent of pi fourths is 1. Then we have 1 minus, again, the tangent of 7 pi 6 is root 3 over 3. Remember, in quadrant 3, tangent's positive. And the tangent of pi over 4 is 1. Okay, so essentially we have root 3 over 3 plus 1, and then over 1 minus, and this ends up being root 3 over 3. Okay. So we have a complex fraction, and so just to get rid of that complex fraction, what we could do is multiply by 3 over 3. And so that gives me root 3 plus 3, and then 3 minus root 3. Well, of course, let's rationalize. And to rationalize, we're going to use the conjugate of the denominator. So we'll multiply by 3 plus root 3. In the numerator and the denominator. So in the numerator, I end up with 3 root 3 plus 3 plus 9 plus another 3 root 3. And then in the denominator, I have 9. And then again, plus root 3 and, plus 3 root 3 and minus 3 root 3, that's going to cancel, we know, because of the conjugates. And then we're going to have minus 3, because again, as in the numerator, root 3 times root 3 is just 3. And so then we end up here with 12 plus 6 root 3 over 6. And each of those can be divided by 6. And so my tangent of 17 pi twelfths is going to be 2 plus root 3. Okay. Now, I know that we could have used the quotient properties, but I think putting this form of sine over this form of cosine is going to be a complete mess. So of course you could do that, but I think it's going to be easier for you just to use the sum formula for tangent to solve this question. Okay. And again, notice that knowing your trig identity or your the trig functions is going to really, really help in this case as far as expediting that process. Okay, so our next question says to use the sum and difference formulas to write the expression as the sine, cosine, or tangent of an angle. And what we want to do is look back on these formulas and basically kind of like work backwards and try to match what the best one is going to be. So if I look here, I see sine, cosine plus cosine sine. So where up here do I see sine, cosine plus cosine sine? And I see that that fits the sine. And I know this says sine cosine instead of cosine sine, but remember commutativity, we're fine. So I can see that this is going to be the sine formula and its addition. So what that means is I'm going to work backwards. It looks like my x here is 110 and my y is 80 degrees. So that's just going to be sine of 110 degrees plus 80 degrees, which means that this is just the sine of 190 degrees. That's all. Okay, in number 4, I have the cosine of 0.88 times the cosine of 0.34 plus the sine of 0.88 times the sine of 0.34. So I have cosine, cosine, sine, sine. What does that match with? Oh, well, that looks like it matches with the cosine formula. And because we're adding, notice that that matches with the cosine of the difference of x minus y. So we're going to need to identify our x as 0.8 and our y as 0.34, but put it in the formula as subtraction. So I can take 0.88 minus 0.34, and I get that I'm taking the cosine of 0.54. So in those questions, just kind of work backwards to see where we're going to be in that case, right? Okay. Example 5, find the exact value of cosine of u minus v, given that the cosine of u is negative 15 over 17 and lies in quadrant 3, and the sine of v is 4/5 and v lies in quadrant 1. So they're giving us two different angles, u and v, and it wants us to find the cosine of u minus v. Well, so it's important for us to see what we're going to need to use in this case. And so kind of leave some space over here on this side, and we're going to want the cosine of u minus v. And so if we use the formula, we know that this is going to be cosine u, cosine v, then we change the sign, plus sine u times the sine of v. Well, they tell us some of this stuff already, right? It tells us that the cosine of u is negative 15/17. And it tells us that the sine of v is 4/5. But we need to do some work to find the cosine of v and the sine of u to put into this problem. So let's take a minute and try to do that. So we'll start with angle u. Let's draw angle u. Again, this is in quadrant 3. And our angle u, it says that the cosine is negative 15/17. So that means that our adjacent over our hypotenuse. And we know that to the left of the origin, this is going to be negative. And then we can find what our missing y value is here. So I have negative 15 squared plus y squared, because essentially that's the y value that we're moving up and down, equals 17 squared. And if you know your triples, you know what it's going to be. But if not, we can work through. We can use the Pythagorean theorem. And we get that y could be plus or minus 8. But in quadrant 3, let's think what has to happen. In quadrant 3, we know that the y value has to be negative, so that y is negative 8. And the reason we needed to know that is because we needed to find the sine of u to help us in our formula. So the sine of u is going to be the opposite, which is -8 over 17, which is the hypotenuse. So now we have that piece of the puzzle, okay? But now we also have this other thing to figure out. We also need to find the cosine of v. So let's draw angle v. And angle v, it says, is in quadrant 1. And it says that that is the sine of v is 4/5. So that means the opposite is 4 and my hypotenuse is 5. Okay. And again, if you know your triples, you know what the answer is going to be. But if not, we can always use the Pythagorean theorem to help us find that missing side length. So I'm kind of flying through this because most of you guys probably know already that that's a 3, 4, 5 triangle. So we can have that x is plus or minus 3. And because we're in quadrant 1, which one would we choose? That's right, positive 3. And remember what we wanted from this is we wanted the cosine of v. So my cosine of v is my adjacent, which is x, which we now know is positive 3, over the hypotenuse, which is 5. And so now we can put that in here. And then we should be able to continue from there. All right, so -15/17 times 3/5. If I multiply numerators, that gives me -45. Multiplying denominators, that gives me 85. Okay, and then here I have -8 times 4 is -32. 17 times 5 is 85. And then I can combine these together to get -77 over 85. And so that, my friends, would be the value of the cosine of u minus v, okay? So if we were to know what angle u was and angle v was, and we subtracted to find this new angle, the cosine of that new angle would be -77 over 85, okay? All right, so let's do another one. Let's verify this identity. If I'm verifying this identity, then I'm going to just work on the more complicated side, which, contrary to popular belief, is not the right, is going to be the left. And what we can do is use our properties again. So notice that we have the sine of a sum and the cosine of a sum. Oh, you know what else I wanted to point out? A lot of times people will look at this and they'll say, oh, that's a cofunction. You guys, that's not the cofunction, okay? Cofunction is when you've got pi over 2 minus theta. So please make sure that we understand that those do not, those are not the same, okay? What we'll do here is we'll use the sum and difference patterns for the sine and cosine. The sum pattern for sine has the sine of the first and the cosine of the second. So we'll take the sine of theta times the cosine of pi. And then sum of sines keeps the sine. Plus, and now we're going to take the sine of the second times the cosine of the first. Okay. Now we're going to utilize the cosine properties. The cosine is we're going to take cosine of the first times cosine of the second. And then in the cosine, we change sign. So since we were subtracting, we're going to then add the sine of the first times the sine of the second. Okay. Well, now notice that as far as the pi's and pi's over 2's, those are angles, so we can evaluate those. We know that the cosine of pi is -1. We know that the sine of pi is 0. Here, the cosine of pi over 2 is 0, and the sine of pi over 2 is 1. So what we see is that we have some terms that are going to be 0 because we're multiplying these by 0. Those are going to cancel. And so ultimately, I'm left with -1 times the sine of theta plus the sine of theta. And we can see that those are going to cancel out and give us 0, which is equal to 0. So we're all good. Okay. All right. All right, the next thing we'll do is solve some equations. This is asking us to find all solutions of the equation in the interval 0 to 2 pi. So I'm going to use a pencil for this one, right small. We'll start out, again, this is not a cofunction because it's not pi over 2 minus x. So we're going to have to use the difference formula for sine. So again, the difference formula for sine is when we're going to take the sine of the first times the cosine of the second. And then we're going to subtract, we keep the sign that was in the original angle, subtract the sine of the second times the cosine of the first. Okay. Now we're going to use the sum rule for cosine. And that's where we take cosine of the first times cosine of the second. And we change the sign minus sine of the first times sine of the second. Okay, sorry about that. All right. Now we can start evaluating. So we have the sine of x. The cosine of pi over 2 is 0. The sine of pi over 2 is 1. And then here I have the cosine of 3 pi over 2 is 0. And then I have minus the sine of 3 pi over 2 is, oops, I forgot the x, is negative 1 equals 0. Okay. So if I look at what I have here, this is going to disappear, okay, because we've got 0 times the sine of x, 0 times the cosine of x. So essentially here I have the negative cosine of x and then minus negative sine of x times negative 1. So if I distribute this negative here, that becomes plus, but then I'm multiplying it by negative 1. So essentially, you guys, we have 3 negatives. And so I'm going to be subtracting the sine of x equals 0. Okay. And we've had something like this before, where we can kind of look at it by inspection, but I'm just going to kind of work you through everything. All right. So what we can do is add sine of x to the other side. And again, by inspection, we might know what it is, but I do want to talk through what would happen if we wanted to actually do the work and solve. So because we're stuck here, we can't turn one into the other because they're not Pythagorean identities. What we could do is we could square both sides. This ends up being, oops, cosine squared x, and this ends up being sine squared x. And then at that point, we can turn one into the other, okay? So if I take cosine squared x and, for example, turn that into 1 minus sine squared x, now I have everything in terms of one trig function, sine of x. So then I have 1 equals 2 times sine squared of x, 1/2 equals the sine squared of x. And so essentially then I know, am I missing something? No, okay. So then I know that if I take the square root of both sides, remember that the plus or minus is when we take the square root, and if I take the square root of 1/2, that ends up being root 2 over 2. So I have plus or minus root 2 over 2. So what that means is that I have several possibilities for this. I have pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths, okay? Which again, we probably could have done by inspection anyway, based on what we know about sine and cosine, okay? But again, I bring this up because if we ever square as one of our tactics, we need to make sure that we're double checking. So what we can do is use this negative cosine x equals the sine of x to check, okay? And so if I look at pi fourths, that's going to be negative root 2 over 2 equals root 2 over 2. That's not going to fly. If I use 3 pi fourths, that's going to be the opposite of negative root 2 over 2 equals root 2 over 2. That works. If I think about 5 pi fourths, that's going to be the opposite of negative root 2 over 2 equals negative root 2 over 2. That doesn't work. And then 7 pi fourths would be root 2 over 2 equals, oh no, negative root 2 over 2 because we're taking the opposite of cosine, equals, and then the sine of 7 pi fourths is also negative root 2 over 2. That works out. So essentially the x values that work here are 3 pi fourths and 7 pi fourths, okay? So yes, I agree that this particular problem is easy to do by inspection based on what we know on the unit circle, but I did just one more time want to go through what happens when we square everything so that you would know kind of like what to look for, like to double check for extraneous solutions in those cases, okay? All right, let's do one more. And the last one we'll do is tangent of x plus pi plus 2 times the sine of x plus pi equals 0. So let me leave some space here. All right, so first we'll use the tangent sum formula. And for the tangent sum formula, we're going to take the tangent of the first plus the tangent of the second over 1 minus the tangent of the first times the tangent of the second. So in the tangent formula, the sign up top is the same and the sign on the bottom is a little different, okay? So then plus 2, and then I'm going to use the formula for sine. So the formula for sine is going to be sine of the first, cosine of the second, and then the same sign, sine of the second, cosine of the first, okay? Now I can evaluate, and I know that the tangent of pi is 0. Oh, that's very helpful, isn't it? That'll help us get rid of a lot of different things, okay? So we can see this particular term, tangent of x plus 0 is going to be tangent of x, and then 1 minus, well, tangent of x times 0 is 0, so that's going to be tangent of x over 1, so that's just going to be tangent of x. So that's super nice, right? So now let's evaluate the rest of this here. Oops, here's the 2. So I have the sine of x, the cosine of pi is negative 1, and then the sine of pi is 0. So essentially this goes away and I'm just left with minus 2 times the sine of x, 0, okay? So again, you'll find that in a lot of these solutions for questions in this section that you're going to end up with a lot of 1s and 0s and negative 1s to kind of eliminate all those extra terms. And so now we want to solve this. Well, I know in the last problem we set them equal and then squared, except tangent we're able to write using sine, right? I could use that the tangent of x is the sine of x over the cosine of x minus 2 times the sine of x equals 0, okay? Now, I don't really want to multiply by the cosine of x. Again, what that does is you're kind of getting rid of that idea and making it equal to 0. But there is a common factor. Notice that there's a sine of x in both of those terms. So I could factor out the sine of x, and then I'm left with 1 over the cosine of x minus 2 equals 0. Well, remember 1 minus the cosine of x is really just the secant of x. And now we have this nice factored form. So we want to find when the sine of x equals 0 and when secant of x is equal to 2. Well, on the interval of 0 to 2 pi, sine is 0 at 0 and pi. And secant of x equals 2, we're really finding when is the cosine x equal to 1/2. Remember, if you need to kind of like think about that, you could do that. And we know that cosine is positive in quadrant 1 and 4. And those would be the values. And I know we always should check, but we didn't square in this case. So just for time's sake, I'm going to say we're good. Okay. And that is just a little bit about using the sum and difference formulas. I hope you have an awesome day. Thanks.